So in this video, the title of the notes are, Review on the XY coordinate plane. This is once again review from IM1. I'm going to be going over a few concepts. The first concept is I give you a formula. This formula was when you have two coordinates and you're trying to find the slope. So look, if I were to graph this, here's my first coordinate. Let's just say, for example, 3 and 5. 3 and 5 is here, and 2 and 1 is here. So let's say here's my line, and I'm trying to find my slope. The formula that I use to figure this out is y2 minus y1. So I said this is my first x and my first y, my second x and my second y. So I said y2, this, minus y1 over x2 minus x1. So I have 1 minus 5, which is negative 4, over 2 minus 3, which is negative 1. So my slope is negative and a negative makes a positive, which is a 4 over 1. So that's my slope using that formula. Or you could also do this. If the coordinates are tiny enough where you can plot them, you could actually figure out how much it's taken to go up and over to get to the next one. For example, if I start here, I go up 1, 2, 3, 4, and then I go over 1. I went up 4 and over 1. You could do that. But if you have big numbers, you're not going to draw a huge graph and count. It's much easier to use the formula. All right, so the next question is this. It says, find the equation of a line. Do you guys remember the equation of a line? Well, I give it to you in your notes. The notes, it says, find the equation of a line which is y equals mx plus b. So I'm going to write that down. I'm going to write down y equals mx plus b. The first thing I have to find is my my slope. Look at the notes. It says, number 1, you got to find your slope. And you have to use the formula y2 minus y1 over x2 minus x1. It gives you a coordinate of 0 and 4 and 1 and negative 3. Okay, so if I'm trying to find my equation, I'm going to start off with y2 minus y1 over x2 minus x1. Negative 3 and negative 4 is negative 7. 1 minus 0 is 1. All right, so my slope is negative 7 over 1. That's the very first step. So I'm going to go back over here to this equation, and I'm going to replace my slope with negative 7 over 1. And the good thing about using a recorded note, the recorded lecture, is you can go back and rewind and re-watch what I just did again as many times as you want to, so you can see what's going on. The next thing is, it says substitute in your notes. It says substitute a coordinate into the equation to solve for your b. So look, here's my equation. Y equals negative 7 over 1x plus b. What I can do is I'm going to rewrite this equation to make it look a little prettier. So I have y equals negative 7x plus b. Here's my equation. I'm going to substitute one of these coordinates into the x and the y. I can either substitute this coordinate into the x and the y, or I can substitute this coordinate into the x and the y. Now, the easier one to use is this, because you should already, for those people who understand graphing, you should already understand that your y-intercept is 4. If you put a 4 here, there's your equation, and you're done. But I'm going to show you I'm going to use this one, because this is a little more difficult, to show you how to find out that this is 4. So, I'm going to plug this into your x and this into your y to solve for your b. So I'm going to substitute this 1 into the x, and this 3 into the negative y. So instead of my y, I'm substituting negative 3. Equals negative 7 times, instead of this x See how this is an x here? I'm going to plug a 1 into here. And now watch. When I clean all of this up, negative 3 equals negative 7 times 1 is negative 7 plus b. How do I solve for my b? I add 7 to both sides to move it over to get negative 3 plus 7 is a positive 4, and that is my b. There's the equation. Now some people might ask, wait, couldn't I use this x and a y to plug into here also? Yeah, you can totally use this, plug this 0 into here, plug this 4 into here and do the math, and this is going to be the easier one to do to get your y-intercept to equal 4. But I just used this one because I just wanted to show you guys the more difficult way to do it. Now, if I lost any of you or if you understood most of it but you got lost for a step, just go back and rewind this video and start off where you got stuck. Take your time, pause it, go on to the next step, unpause it, and it's going to make it a lot more sense. Okay? Now, the next thing is called the distance formula. And this is just a formula that you have to remember. There's two ways to do this. I give you the formula. And I'm going to show you the easier way and the harder way to do this. So let's take two coordinates. Let's say we have 3 and 8. And negative 4 and 1. So if I were to graph this, look, 3 and 1, 2, 3, 4, 5. 3 and 8 is right here. Negative 4 and 1 is right here. Question is, how many units is it from here to here? There's a formula that you can use on your notes. I give you that formula. And I'm going to do this real quick. I'm going to show you a much easier way to do this. So the formula is, it's the square root of x2 minus x1 squared plus y2 minus y1 squared. That's the formula from your notes that I give you. All right, so if I simplify this, negative 4, negative 3 is negative 7. Squared, which is 49, plus 1 minus 8 is negative 7, squared, which is 49. And it's the square root of this whole thing. So 49 plus 49 is the square root of 98. Square root of 98 is like 9.9 or 9.8, something like that. So anyways, this is about 9.9 or 9.8 units. Okay, that's the more difficult way when you're using the distance formula. The easier way, I think, to do a question like this is, if you remember last year with Pythagorean theorem, watch this. If I make a right triangle from here to here, I'm going to redraw this right triangle. From here to this point, I went 1, 2, 3, 4, 5, 6, 7. I went 7 units over. And then from here to here, I went, let's see, 1, 2, 3, 4, 5, 6. Is that right? Oh, wait. No, I went 7. I'm sorry. 7. I went this because this is 1. This is up 7. I'm going to go up 7 as well. This is a right triangle. This right here is the distance. This is what you are trying to find right here. This length right here is what we found using the distance formula, which is like 9.8 or something. Well, look, you can actually use Pythagorean theorem. It's a right triangle that I just created. This is 7 units to the right. This is 7 units up. A squared plus b squared equals c squared. A squared, which is 49, plus b squared, which is 49, equals c squared, or x squared. We'll just call this c. 49 plus 49 is 98, equals c squared. And how do you get rid of a square? You should remember from IM2 last year, to get rid of a square, use square root. So the square root of 98, which is what we just had using the distance formula. Okay. Once again, if I lost anybody on that, Go back, start from the beginning, and go slow. Pause it each step of the way till you understand what I said with the first step, and then go on to the second step and so on. Okay, the next part of these notes, I'm going to be going over some vocabulary with you. This was taught last year. The first thing is called decreasing. If you start from the right to left on any graph, it's either constant, consistently increasing, consistently decreasing, or staying the same. So pretty much if it starts up but then it goes down as it gets over to the right, it's called decreasing in value, because the value on your y's are getting smaller the further you go. Where this graph right here, look on your notes, this is called increasing, because the numbers on your y's, you go from left to right, the y numbers get bigger. So if you were to go way over here and touch the graph, you'd be much higher on your y than on this graph. If you were to go way over here and touch the graph, you would be much lower on the y. So this is decreasing because from left to right it's getting smaller. This is increasing because from left to right it's getting larger. The next thing is called discrete. Discrete data is when you have points of data, where this right here, there's no space, there's spaces in between each. This is called continuous data. Continuous just doesn't mean that there's an arrow, because it kind of sounds like if somebody says something's continuous, then it's continuing forever. That's not what it means, because these technically have arrows as also, but they're not continuous. They're discrete because they're incremental. Where there is no incremental. It's one set of data. An easy way to remember between the difference of discrete and continuous. Discrete are a set of coordinates. Discrete or continuous means there's no gaps between all the data. It's just one straight line. This is called a piecewise function. And on the notes, that's all I give you about that. Piecewise means it stays a certain amount of point and then certain amount of data and then it jumps up. So let's say this is your what's it called your allowance. So this is, let's say you start earning let's say $20 a week when you are 10 years old to 11 years old. So every year from 10 to 11 you earn $20 a week. Right after you're 11, from 11 to 12, let's say you earn $30 a week from 11 to 12. And then right after you're 12, from 12 to 13, you earn $40 a week. This is called continuous. So if you were to look at this graph and go, when you were 10 and a half, how much money did you earn a week with your allowance? 10 and a half, you earned $20. When you were almost 11 years old, how much money did you earn on your allowance? Almost 11, you still earned $20. How much money did you earn when you just turned 13? Well, when you just turned 13, you'd earn $40 a month. This is called piecewise, or it's also called a step function, because it stays the same for a certain amount and it doesn't increase incrementally. It just jumps up and it stays the same, and then it jumps up and then it stays the same. Okay, the very last thing on these notes is rotating. Rotating, and this is from IM1 last year. So the two rotations that I'm going to be asking you about is 180-degree rotation. If you remember, if you have an X and a Y, but you change the sign on the X and change the sign on the Y, that equals 180-degree rotation. Where if you have an X and a Y and you just change the sign on your Y, it rotates it over your X axis. And then if you have an X and a Y, but you just change the sign on your X, it rotates it over your Y axis. That's review from last year. You're going to have a couple questions over that. The other thing is, look at the example that I gave you. I said graph triangle ABC. All right, I'm going to graph triangle A, B, C. So A is located at -1, -4. B is located at 3 and 2. And C is located at 2 and -6. And it's going to ask you the lengths of these sides. Now what I would do is this. You can use the distance formula to find the lengths of all of these, but probably what I would do, I think it'd be much easier if you create 3 right triangles. Look, to get from here to here, you would go over to the right one, up however many this is, and then you could find this side, because if you were to rewrite this right triangle, it's going to look like this. This is over to the right one, up a certain amount, and then a squared plus b squared equals c squared, which is this right here. Same thing for here. Look, to get from here to here, you would go, it looks like you go down 1 over a certain amount to find the length to here. So this would be another right triangle. And then to go from here to here, you would go up a certain amount, over a certain amount to find this length. Up a certain amount, over a certain amount to find this length. So you're going to be using the Pythagorean theorem 3 different times to figure out the lengths of those. You're going to have a couple questions about that as well. So at the very end of your notes, it says number 2 in dark black letter or number. And all this means is this is the second assignment from the book. That's it. And then it says 5AB, 60, 64, 89, and 115. That means that you are going to be doing those questions on a separate piece of paper. The answers to these questions are attached to where these notes were as well. All right.